Okay, we're going to continue our discussion on Chapter 3, Quadratic Function, and we're looking at quadratic equation and inequalities. All right, so when we have the second order equation, it would be a form of ax squared plus bx plus c is equal to 0. In this case, as you see, a, b, and c are real numbers, and a cannot be equal to 0 because we want to have a second order equation. And in this example, we want to consider p of x to be 2x squared plus 4x minus 16. P of x is equal to 2x squared plus 4x minus 16. This is like if you have y is equal to 2x squared plus 4x minus 16. So we're going to take a look at the solution of this second order equation. See for what value of x, 2x squared plus 4x minus 16 is equal to 0. That would be when we let y be equal to 0 and solve for x, that would be my x-intercept. And if I let x be equal to 0 and solve for y, that would be my y-intercept. So one way to solve a quadratic equation, p of x equal to 0, is to use the factoring and the zero product property. So basically we need to factor, so we need to get our equation in the form of product of binomials so we can solve for each of those x. So in this case, let's take a look at the example. We have 2x squared plus 4x minus 16 is equal to 0. In order to solve, we need to factor this. So in this case, we have 2x squared plus 4x minus 16. As you can see, all of these are factor of 2. We have 2 in common among these. Okay, because this is an equation, I can divide each term by 2. So this I would get x squared. This would give me 4 divided by 2, give me 2. 16 divided by 2, that give me 8. So negative 16 becomes minus 8. So this is a little simpler to factor now. We can use a trial and error method for factoring. We get x plus 4 times x minus 2. Recall that you look at negative 8, look for two numbers. When you multiply them together, you get negative 8. When you add them up, you want to get plus 2. And we could confirm that by looking at the two middle term and two furthest term. You get 4x minus 2x. That give you 2x. So everybody should know how to factor by now. So we get x plus 4 is equal to 0. So one solution would be x equal to negative 4. And we get x minus 2 equal to 0. And the other solution would be x is equal to 2. So this would be the solution for that equation. So note that the zeros of p of x, if I call this p of x, is equal to 2x squared plus 4x minus 16. The zeros are then negative 4 and 2. These are the zeros of this polynomial. So what that means is when y is equal to 0, x is equal to negative 4 or x equal to 2. This would be where your parabola, this looks like a parabola, intercept your x-axis at this point. These are your x-intercepts. So if you use your graphing calculator, you can confirm these results by looking at where the graph going to intercept x-axis. And that would be, if you trace them, exactly the points that we calculated. Let's find the zeros of the quadratic equation of p of x equal to x squared minus 6x plus 9. Remember, we need to write that equal to 0 and then factor them. So this is special factoring. It says x minus 3 times x minus 3. So if I factor this, you can use a trial and error method, put x, and that would be 3 and 3. Looking for two numbers, when you multiply them together, you get 9, would be 3 and 3. And then when you add them up, you want to get negative 6, so both of these has to be minus. So it would be x minus 3 squared equal to 0. So notice that you would get same exact answer or get two identical solutions here. So there is one distinct 0, 3. It sometimes is called double zero or double solution roots in this case, because they're identical. And we can easily confirm that also by plugging that equation into your graphing calculator, and you can see the solutions right there, confirm our calculation there. If you have x squared is equal to k, if you have something square is equal to a number like k, remember the square root property, x would be equal to plus and minus square root of k. Or if you solve this and move everything to one side of the equation, this would be really x squared minus k is equal to 0. And you can see that this is a difference of square. X minus square root of k times x plus square root of k. So you can look at it as x is equal to still plus and minus k. So if you look at the result here, if k is greater than 0, or if k is equal to 0, or k is less than 0, you would see that would be no real solution here. We have one solution here at k is equal to 0, and here you can get two solutions. So let's take a look at these two examples. Solve 2x squared minus 10, and then solve 2 times x minus 1 squared equal to 14. Now is a good time for those of you watching this maybe later at home to pause the session so you can get the same answer that we get here. For the first one, if I divide both sides of the equation by 2, I get x squared is equal to minus 5. Remember, if I have x squared is equal to k, x would be equal to plus and minus the square root of k. Your k is minus 5 here. So in this case, if I have x squared is equal to minus 5, x would be equal to plus and minus square root of minus 5. Remember, when you have a minus under the radical, that would be square root of minus 1 times square root of 5. What are we going to replace with square root of minus 1? I. That's imaginary number. So it would be plus and minus I radical 5. So that's why we get this x equal to plus and minus I radical 5 here. For the second one, if I divide both sides here by 2, I get x minus 1 squared is equal to 14 over 2, which is 7. And notice that, recall, x squared is equal to k means x is equal to plus and minus the square root of k. So in this case, your x is this expression. So you would say this expression here, x minus 1, must be equal to plus and minus the square root of 7. So you just simply solve for x by adding 1 to both sides of the equation. So x would be equal to 1 plus and minus radical 7. Again, we can confirm all these results using your graphing calculator, where you get no solution or two solutions. There will be the intercepts there. Let's take a look at this example here. Solve each equation by completing the square method. Okay, if you recall, I gave you a quiz last time on this topic, and please pay attention, everyone. For those of you following this session live, you're going to get a quiz on completing square after this lecture today. So let's review the lecture, the method again. Once again, if you have x squared minus 4x plus 2 is equal to 0. Anybody remember what would be the first step when you solve a completing square method? You want to make sure that the coefficient of x squared is equal to what? 1. Okay, so in order the method that we're going to presenting here to work for us, we want to make sure that the coefficient of x squared is equal to 1. Sometimes it's not equal to 1. Then we need to either factor it out or divide each term by that coefficient to eliminate that. So in this case, the coefficient of x squared is equal to 1 already. So what the next thing we're going to do is we're going to move this constant to the other side of the equation, because I don't really need this 2 to complete the square. So I'm only going to use x squared and negative 4x to complete the square. If the coefficient of x squared is equal to 1, you take the coefficient of x and you divide it by 2 and you square them. And that's the number you need to add to both sides of the equation to complete the square. So you get negative 4 divided by 2 would be negative 2. You square that, you get 4 plus 4. So everybody should see why I'm adding 4 to both sides of the equation now then. Okay, I obtained that by finding the coefficient of x, negative 4 divided by 2 and square them, and that's the magic number I need to add to both sides. When you add that number to both sides of the equation, the left-hand side not only would be factorable, also would be the same binomial. So if I factor this by trial and error method, that would be x and x. That would be 2 and 2. Both has to be minus. You see, it would be x minus 2 times x minus 2. So adding that 4 guarantees to get something square here, which is x minus 2 squared. So once I get it to this point here, then I can use the square root property theorems to solve for this. Remember, if I had x squared is equal to k, x would be equal to plus and minus square root of k. So your x is x minus 2. So x minus 2 must be equal to plus and minus square root of 2. then you just simply solve for x. So this is solving by completing square method. You make something square on the left-hand side and use the square root property to solve for x. So that would be your solution. So remember that when x squared minus 4x plus 2 is equal to 0, if I use completing square method, I would get x equal to plus and 2 plus and minus are equal to. This is where your parabola going to intercept your x-axis at those points. Okay, let's take a look at this one. 8x squared plus 2x minus 3. We want to use the completing square method. Once again, if you're watching this later at home, you can pause the session, see if you can get the same results. So what we need to do first is to make sure that the coefficient of x squared is equal to 1. Okay, so here I need to divide each term by 8. If I divide this by 8, this by 8, and this by 8, then I would get x squared, not the coefficient of x squared is 1. 2 over 8 would be equal to 1/4, equal to 3 over 8. I need to add something to both sides of the equation here to complete the square. We said we're going to take the coefficient of x, which is 1/4, divide it by 2, and then square it. Okay, what is 1/4 divided by 2? 1/4 divided by 2 would be multiplied by 1/2, right? You change the division to multiplication. So this would be 1 over 8 square. What is 1/8 square? 1 over 64. So everybody see why I'm adding 1 over 64 to both sides of the equation here then? So if you add 1 over 64 to complete the square on the left-hand side. So the left-hand side not only going to be factorable, also the same binomial when you factor it. So if I open two parentheses here, this one right there, that would be x and x. Okay, this number here after you complete the square always would be square root of this number, which is 1/8. 1/8, you can always confirm that. 1/8 times 1/8 is 1 over 64. Then you multiply the two closest term and two furthest term, you get 1/8x and 1/8x, I give you 1/4x. Everything there is, it would be 2/8, which is 1/4. Okay, so on the left-hand side, you get x plus 1/8 square, and then these two, of course, we need to add them up, right? What's the LCD here? 4. 4? LCD is between 8 and 64. Is 64. You have to multiply this by 8. If I multiply both sides of the equation by 8, I mean top and bottom here by 8, multiply this by 8, multiply this by 8, that would be 24 over 64 plus 1. 24 plus 1 would be 25. Okay? Remember how to add fractions. Okay. X plus 1/8 squared is equal to this. Now I can use the square root property to solve for this. Remember, if something squared is equal to k, x would be equal to plus and minus radical k. So now I'm ready to do that. X plus 1/8 is equal to plus and minus square root of 25 over 64, which is 5/8. So x would be equal to minus 1/8 plus and minus 5/8. So you get two solutions here. One solution would be minus 1/8 plus 5/8, which is equal to minus 3/4. The other solution would be minus 1/8 minus 5/8 would be 1/2. You get two, these would be the zeros. The quadratic formula. Okay, you probably remember the quadratic formula from the previous math classes you took. This is the minus b plus and minus b squared minus 4ac divided by 2a. If you recall, this is the formula you need to remember. If I have a x squared plus bx plus c is equal to 0, when you go through these calculations here, you get x is equal to minus b plus and minus square root of b squared minus 4ac divided by 2a. So pretty much these steps using that completing square method and square root property would help us to arrive to this formula. So we're going to use that. So I'll let you pause this and take a look at each step here as how we completed the square using the method we learned and to get to the quadratic formula. So we need to remember that, put this in your summary sheets. Now what's important about this is what we have under the radical here. If b squared minus 4ac discriminates, let's call it discriminate part. If b squared minus 4ac is equal to 0, then you would get like two identical solutions. One real double solutions. You get minus b plus 0 over 2a minus b minus 0 over 2a. So you get the same identical answers. If b squared minus 4ac is greater than 0, then we get two solutions, right? Two real solutions. And if you get b squared minus 4ac less than 0, then you get a negative under the radical. Then you're getting those i's. You then get complex. You get two complex or not real solutions there. Let's take a look at solving equation. Here we have x times x minus 2 is equal to 2x minus 2. Again, once again, this would be a good time to pause the session, see if you can get the same answer as us. So here, what we need to do is to go ahead and rewrite this to make it look like a standard form. Okay, so I can distribute this. I get x squared minus 2x and move everything to one side of the equation. You get x squared minus 4x plus 2 equal to 0. And then your a in this case is 1, your b is minus 4, and your c is 2. So I can use the quadratic formula and substitute for each a, b, and c's the corresponding value. And then we find x is equal to 2 plus and minus radical 2. You notice that we had a similar problem here. We used completing the square method. We got the same answer. So you can get the solutions by using the quadratic formula. We can easily confirm our result using a graphing calculator and see where my problem is going to intercept x-axis. And as you can see, you get very close to what we calculated. Using the quadratic formula, 2x squared minus x plus 4 equal to 0. So in this case, again, x is equal to 2. Your a is equal to 2. A is the coefficient of x squared. Your b is minus 1. Your c is 4. And you just basically substitute the values. And then in this example, you see you get a negative under the radical. So we're going to separate that negative 31 to negative 1 times negative square root of 31. This would be I, radical 31. So that's where this I come from. This is a complex number. And this would be our solution. 1/4 would be a real part plus and minus I square root of 31 over 4. And again, as you can see by graphing the parabola. If the parabola opens upward, A is positive. If the parabola goes downward, A is negative. And that's exactly what happens is if P of X is equal to 0, then we get these solutions here. We get A and B. You're probably going to intercept at these points on the x-axis. If it's greater than 0 would be these intervals here. These are the numbers that are greater than 0. And less than 0 would be this right here. So it would be all the numbers that in between those. And similarly, if I have the parabola opens downward, it's P of X equal to 0, the solution would be A and B. If P of X is less than 0, then you can see the solutions would be all the number from negative infinity to this point would be less than 0. These are the green part would be less than 0. So all the number from negative infinity up to this point and all the number from this point B all the to positive infinity, then would be less than 0. If it's greater than 0, this would be a portion that would be larger than 0. So it would be all the number between A and B would be the portion where it is greater than 0. So we can look at the graph to confirm all those results also. And then this would be the case where your parabola opens upward or downward, and then you get only one solution here on the x-axis. Again, similarly, you can see if it's P equal to 0 or greater than 0, less than 0, depending what situation we have. Then we can see if the solution would be within the negative infinity to A, or from A to positive infinity, or or would be no solution in some cases. Like if P of X is greater than 0, so there's no point on this graph here because the parabola opens downward, the parabola is not greater than 0, so that would be no solution there. So these graphs will also confirm the results. And this would be another case where you don't get any solutions here. So this would be where you get the imaginary solution there. So P of X equal to 0, well, there's no solution here, no solution. If it's greater than 0 or less than 0, it shows where it would be negative infinity, positive infinity, in this case when P of X is greater than 0. So if the parabola opens downward, similarly, you can see each of these situations by just looking at the graph. Solving a quadratic inequality now. Let's take a look at that. Now you can go ahead and pause the session and read these steps and see how it goes, but I'm just going to go ahead and jump right into the example here. So if I have x squared minus x minus 12 is less than 0, what the first thing you want to do here is to find the zeros, the roots. In this case, we need to factor this and see at what point x would be equal to 0. Where at what point this parabola going to intercept x-axis. If we solve this for x, and you can see it would be x equal to -3 and x equal to 4. So when that happens is you want to locate those zeros, -3 and 4. When you get two solutions, you create 3 regions, 3 intervals. All the number to the left of -3, all the number between -3 and 4, and all the number to the right of 4 could be the solution. Now, how are we going to see which region is the solution, which interval would be a solution? We just pick a point. We just pick a test point in that region and simply check if it checks out or not. It's very simple. So you can pick any number you want from -infinity to -3, see if that works. That would make this is less than 0. If you look at the 3 regions, we can test those out. So in this case, we have x squared minus x minus 12 is less than 0. If you look at all the number from -infinity to 3, so let's draw the figure here again. Let's put it down here. So from we just said -3 is right here. All the number from -infinity to -3 would be this region here. Pick a point, any point you want within this region. So in this case, we're picking a test point of -4. -4 would be the one that we can test. If I substitute -4 into that inequality, does that make sense? Well, let's see. -4 squared minus -4 minus 12, is that going to be less than 0? This is 8. 8 is less than 0. No, 8 is not less than 0, so it's false. So my solution cannot be from -infinity to -3. That's all you have to do, just pick a point in that region and test it. If you recall, the next one was 4, right? So if I go to 4 here, let's say this is 4. From -3 to 4, let's pick a number. The easiest number probably would be 0. If I substitute 0 in this inequality, does that make sense? 0 minus 0 minus 12 is less than 0. Yeah, that makes sense. Minus 12 is less than 0. So all the numbers from -3 to 4 then must be the solution, because that is true, that works. From negative, all the number from -3 and 4 must be the solution. The solution often alter between these intervals. So when there's no solution, so this shouldn't be a solution either then. But we can confirm that easily by picking a number like 5. If I substitute 5, you can see that it's not going to work. 5 squared minus 5 minus 12, less than 0. 8 is not less than 0, so that's false. So the solution must be between -3 to 4, just by finding the zeros and picking a number within those intervals, see which one works. So we can easily also confirm the result using our graphing calculator, and you can see at what region we would have this polynomial would be less than 0. So all the number from -3 to 4 as we calculated, the values would be negative. The calculator can show that. Let's take a look at this example. Solve 2x squared greater or equal to minus 5x plus 12. This would be also a good time to pause the session and see if you can get the same answer. The first thing we're going to do is we're going to move everything to one side of the equation and kind of work this out and find the zeros. Okay, if I move everything to one side of the equation, I get 2x squared plus 5x minus 12 equal to 0. If I factor this, I see my zeros would be 2x minus 3 is equal to 0, x minus 4 equal to 0. So I get x equal to 3/2 and negative 4. So if I locate those on the number line, then I can see I get, again, 3 regions, negative infinity to negative 4, negative 4 to 3/2, 3/2 to positive infinity. These are the 3 regions that I have to test. Okay, basically I need to pick a point, like minus 3 here. I can pick 0, and I can pick a number to the right of 3 over 2 and see if it works out. Which interval would give me a correct answer here. So if you look at, if I pick minus 5 and plug it into the equation, you can see if that turns out to be true. This time, the region altered. Remember we said no solution, solution, no solution. The interval again alters, the solutions alter between those regions. So as you can see, 0 is not going to check out, okay? But if I pick a number to the right of 3 over 2, like 2, it's going to work out. So the region would be true when it's less than infinity, from minus infinity to negative 4, and to the right of 3/2. So all the number from negative infinity to negative 4 would be the solution. And all the number from 3/2 to the infinity would be a solution. So that's all you have to do, just pick a point within those 3 regions, see which one works. And we can easily again confirm our answers using our graphing calculator to see which portion would works here when it's greater or less than. So let's take a look at this example. Previously, remember we found the solution to x squared minus 4x plus 2 is equal to 0. We used the completing square method, and also we used the quadratic formula to find x equal to 2 plus and minus radical 2. If you recall, we did that in 2 different methods. So if you look at the parabola, this would be where your parabola going to intercept at this point. 2 plus radical 2, 2 minus radical 2. And if you recall, we have v of x equal to minus b over 2a. If I use a shortcut, I can find the location of the vertex here, which is the lowest point. This parabola opens upward, and the y-intercept can be easily obtained. If x equal to 0, y is equal to 2. So you can kind of see the solutions here. The graph is in this case. So in this case, at these 2 points, you're probably going to intercept x-axis. So if you want to be greater or less than, then we can see at what point would be greater. So if you go from negative infinity to this point, and from 2 plus radical 2 to positive infinity would be greater than 0. For less than 0 would be all the graph below that. So that would be between minus 2 plus 2 radical 2 and minus radical 2. That would be where it would be less than. So you can see those 2 regions as the solutions. All right, let's take a look at solving the equations that involve more than 1 variables for 1. So in this case, when we have a is equal to pi d squared over 4, we want to solve for d. So when you're solving for d here, you want to treat the other variable as a constant. So in this example here, I can cross multiply this. One step is to cross multiply. Let's look at the steps here. So I get 4a is equal to pi times d squared. To solve for d, I need to divide both sides by pi. So d squared is equal to 4a over pi. So d would be plus and minus square root of that. So the d would be equal to plus and minus square root of 4a over pi. So we're using the square root property to isolate d in this case. The second one, we have rt squared minus st plus k. So in this case, We're going to move everything to one side of the equation. Remember, we're solving for t. So it looks like I need the quadratic formula to solve for t. In order to do that, the coefficient of t squared would be r. So my a is equal to r. So my b is minus s, and my constant is minus k. So these are the values we're going to place in your quadratic formula. Everywhere you see b, you're going to put minus s. Everywhere you see a, you're going to put r. And everywhere you see a, you're going to put r here. And then that would be your equation t in terms of the other variable.